In our modern-day world, we come across small problems and solutions to them every day. However, there are a large number of problems that still remain solutionless, such as deforestation, climate change, gender equality, water shortages, aging populations, terrorism, diseases, data security, education provision and rights, energy sources, global warming and housing shortages, to name but a few. In particular, I'm going to focus on energy resources and how we can overcome problems of depleting fossil fuels with new innovative methods of energy harvesting. Modern civilization cannot function properly without electricity. As sad as it sounds, it's true. Computers, company systems, street lamps, and many more important devices to make our lives easier and to keep things running smoothly rely on electricity. Cars and vehicles also rely on petrol and other fractions of crude oil to work properly. However, the fossil fuels that are burnt to release the energy we need are a finite resource, and one of the biggest challenges of the 21st century is finding alternatives. Experts say that the UK only has about 5.2 years left of oil, and for many EU countries that number is even lower. This means that soon we will be relying heavily on imports from oil and coal-rich countries like Russia and Norway, but eventually their supplies will be depleted as well. We need to turn to more renewable energy sources. In 2009, only 19.5% of the world's electricity was generated by renewable sources, such as wind turbines for wind, hydroelectric generators for water, and solar panels for sunlight. My question to the engineering world is, why don't we turn excess into electricity? Why don't we turn sources that would otherwise be wasted into useful power? One way of converting biodegradable waste into energy is through anaerobic digestion. The process of anaerobic digestion turns waste into methane, carbon dioxide gas, and fertilizer. Industrial anaerobic digestion tends to take place underground, where the temperature is higher because of the insulation from the soil, as the bacteria work better in warm conditions. Anaerobic digestion is an ongoing process whereby the waste, namely manure, is piped in one side and the biogas, which rises to the top of the container, is extracted from the other side. The container is also airproof so that no oxygen gets in, otherwise the anaerobic bacteria will not respire and break down the waste material. This process produces carbon dioxide, biomethane, and compost. Carbon dioxide is useful for its properties as a solvent, its heat transferability, and as an inert gas. The compost is that which has been broken down into basic chemical compounds, so it is naturally thoroughly decontaminated. Although this does not create electricity specifically, some of the products can be burnt to create electricity in the same way as burning coal to create electricity. Another way of turning waste to wanted is by using a microbial fuel cell. The microbial fuel cell, or MFC for short, is a relatively new idea which I'm really interested in, as it combines the need for electricity generation and also the need for adequate water sanitation that 2 million people in the world lack. The MFC generates electricity directly from organic materials using bacteria. MFCs consist of two chambers, an anaerobic anode chamber and an aerobic cathode chamber. In the anaerobic chamber with the anode, bacteria remove electrons from the organic material like wastewater and then transfer them to the anode. The electrons then pass through a resistor to the aerobic cathode chamber, where they combine with protons and oxygen to make water. When the electrons flow from the anode to the cathode, they create an electric current. This type of electricity generation can be used particularly in sewage treatment plants, where lots of electricity is needed to treat the water, so they can clean the sewage from the energy of sewage. It could also be revolutionary in developing countries, where it is too expensive to treat sewage, and electricity is a luxury. MFCs allow for electricity generation and the production of safe drinking water at a much more affordable price than large generators or water sterilisation plants. Although there still needs to be more research into it, I think that this has real potential for being a life-changing piece of engineering for so many people. If we look at the possibilities of waste conversion from a different angle, What if we could generate power from excess heat? Thermophotovoltaic devices are similar to the solar panels or photovoltaic devices on our roofs. The difference is that not only do they convert the visible light portion of the spectrum to electricity, but also the infrared portion felt as heat. The semiconductor material in the thermophotovoltaic material captures the light, and the electrons gain energy and flow out of the material as current. Thermophotovoltaic materials work best in temperatures above 1000 degrees Celsius, which is ideal as so much heat is wasted from industrial processes in places such as glass and steel refineries, where process temperatures exceed 1000 degrees Celsius. There is lots of potential for this kind of waste conversion technology. In the future, there could be thermophotovoltaic materials anywhere there is a constant heat source, turning waste heat into electricity. One possibility could be in a car engine, using the electricity produced to power the car, or in the lofts of houses to capture escaping heat and put it back into the house as electricity. There are so many possibilities for waste conversion to energy through engineering, and I think it's a really important area of research that will benefit the planet hugely in the long term. Energy cannot be created or destroyed, so who knows? There may be energy out there just waiting to be turned from waste to wanted.